Ladies and gentlemen, I'd like to go back to the issue of quantitative laboratory services to finalize what we have just discussed last time. This is by displaying what's known Westgard rules. Westgard, it is a complementary presentation to that issue. As we discussed last time, that control chart which I have utilized is concerned with the situation when the laboratory is using only one change or only one quality control material. And we said the values obtained by examining that control materials together with which has been examined together with the patient samples, if that value lies outside plus or minus 2 standard deviation, the measurement is expected to be unacceptable. But it is better to use more than one control material within each run in the laboratory. So in case of laboratories using two control materials or more, the best rules to be followed to assess and interpret the results and the findings is the Westgard rules. And those are multiple rules developed by who is known by Westgard. It is very necessary to include and to discuss those rules because they are complementary and they are complete and they are useful to maintain and manage the quality of quantitative services in the laboratories. A multiple rule system developed by Dr. James O. Westgard based on a statistical concept like that one of Levy and Jennings chart. A combination of decision criteria or rules to assess if a system is in control. It is actually a combination of problems, a combination of decisions. This is why we are using two or even more than two control materials so as to exceed the range and the value and the possibility of the decisions that you are going to undertake. Westgard rules are used when at least two levels of control, when at least two levels of controls are run with the examination run. And Westgard rules cannot be used within only one when only one control level is used. As we said before, this is unique to utilization with Levy and Jennings chart. Westgard multi-system rules. Those are the titles of the Westgard rules. The first title is 1 2s rule and 1 3s rule, 2 2s rule, and 4s rules, and 4 1s rule, and then 10x rules. In details, Westgard 1 2s rule is a warning rule. It is not cause of rejection of the analysis system that you have carried out. So results obtained by using this rule are not rejected and are not cancelled. But one of two control results fall outside plus or minus standard deviation. One of two control results, because it indicates that the laboratory is using two control materials. One value obtained from analyzing control material lies outside plus or minus 2 standard deviation. So it is a warning. It alerts analysts to possible problem. You do not need to reject or to cancel the analysis, but you take an action and investigate to see what is potential problem behind this phenomenon. This rule must then evaluate the 1-3 standard deviation rule. If this happens, if one of the values lie outside plus or minus standard deviation, accept the measurement, but you need to evaluate that rule of 1-3 standard deviation rule. The Westgard rule number 2 is a cause of rejection, which is 2 standard deviation rule. 2 to 1 standard deviation rule. It is a cause of rejection. Two consecutive rules or consecutive control values of the same level fall outside plus or minus 2 standard deviation in the same direction. This is one phenomenon. Two consecutive control values, consecutive coming immediately following each other, one behind the other or one after the other, of the same level, either two normal control values or two abnormally high control values or two abnormally low control values lie outside plus or minus 2 standard deviation together, and this indicates that multiple control materials may be used, not only two control materials. This is one phenomenon. And the other phenomenon of this rule is that both controls in the same run exceed plus or minus 2 standard deviation. Both controls, if you are using two controls, both values of those controls within the same run exceed plus or minus 2 standard deviation. Also in this case the measurement is rejected. Patient results cannot be reported. That is the rejection, and this requires corrective actions. You need to investigate, to study, to understand the cause of that problem and the source. Then you solve that error and return to re-examine the patient's samples again, and to make sure that those results are free from defects and free from weakness. Westgard rule, R4S rule, is also a cause of rejection, and it is that one control exceeds the mean by 2 standard deviation, the mean by minus 1 standard deviation, and the other control exceeds the mean by plus 2 standard deviation. It means that the system comprises multiple control chains or only two control materials. The value of one control material is above the mean by plus 2 standard deviation, and the other is below the mean by 2 standard deviation. It means that the variation between the two levels is complete for 4 standard deviations. The range between the two results will therefore exceed 4 standard deviations at least. So random error has occurred. Test run must be rejected. We preceded before that random errors are not always because of rejection, but in this case the range is very big and the errors are very high actually. So this is why the measurement should be rejected. It should be rejected, situation investigated, errors pointed out, and the causes of the errors are identified and the sources actually identified. Then measurement, corrective actions are adopted and implemented, and after that re-examination or resumption of the examination takes place, and the results obtained should be evaluated for being free from defects and free from weaknesses. Westgard rule 4.1s is also a cause of rejection. It indicates it requires control data. It requires control data from previous runs. You need to go back and to glance and to search and to look for, to review the control data previously examined. And it indicates that four consecutive QC results for one level of control are outside plus or minus 1 standard deviation, or both levels of control have consecutive results that are outside plus or minus 1 standard deviation. These are the forms: either 4 consecutive quality control results of one level of control, either normal or abnormally high or abnormally low. 4 consecutive results are outside plus or minus 1 standard deviation, or both levels, normal and abnormal, both values of control materials have consecutive results that are outside plus or minus 1 standard deviation. Westgard rule, the last one, which is 10x rule, is also a cause of rejection. It means that if it happens, measurements should be rejected immediately, and this requires control data from previous runs, like the one before this. You need to collect or to review the data of the control materials lastly carried out to see if there are any abnormality that leads to the same problem or to the current problem. 10 consecutive QC results for one level or level of control are on one side of the mean. 10 consecutive values of the same control of the same QC results of one level of control are on one side of the mean, or both levels, normal and abnormal, of control have 5 consecutive results that are on the same side of the mean. Either 5 consecutive measurements of two levels of control materials on one side of the mean, or 10 consecutive values of one level of control on one side of the mean. Measurements should be rejected immediately, situation analyzed and investigated, problems and the source of the problems pointed out, errors resolved, and after that the resumption of the examination of patient samples used to take place, and they used to be assessed for being correct and free from defects, and after that service is to be issued. Actually, use Westgard Matrix system to describe the control values of each day in the following site, and this is a homework that I would like to find the solutions from your side, which will indicate your successful attendance of this course. These are the phenomena indicated by days. These are the days of examination. These are the days of measurements of the control together with this one, because we are using two controls. This is the chart of one level of control, and this is the chart of the other level of control in the same days, starting from day 21 to day 44, and these are the measurement values which have been obtained. The questions vicinity, I would like to everyone to analyze those problems and point out the abnormalities or the normalities which has been indicated by those two graphs, as indicated by Westgard rules. And after that we will have to discuss together to point out the errors. Thank you very much and have a nice day.